Hello everyone to this week's webcast on improving Java and Android build performance. My name is Dockter. I'm the founder of Gradle and the CEO of Gradle Inc. And with me is Stefan Oehme, the lead of the Gradle core team, and his major focus over the last 12 months and for the next 12 months, I guess, is performance. So yeah, we're very excited to have you here in our San Francisco office and can't wait to see the presentation.
Happy to be here. Before we dive into optimizing performance, maybe we should talk about what happens when your build is not fast enough, right? Yeah. So why are we here?
Why are you interested?
Slow builds have a cost. I just made up this simple example. Imagine you have a medium-sized team of 50 developers. Each one of them does 50 builds per day, maybe by clicking run in the IDE or something like that. It's not an outrageous number. And each time you do that, you have to wait, let's say, 60 seconds until you can try out your app or see your test results, right? That's 42 hours every day. Or in other words, a whole developer week wasted every day. And 60 seconds, that's just the raw build time, right? If my incremental build takes 60 seconds, I'm gone. I'm off to Twitter or getting a coffee. So the real time that I lose there is probably higher.
Yeah. So, and just to add to that, if you're interested in the kind of the economic perspective on builds, so we have a really great blog post on that. It's called The Costs of Build. You can find it on Gradle.com or just Google for it, The Costs of Build. And that goes into great detail, right, in exploring, right, the cost of build for an organization. I think one key reason why organization endured the situations we often see out in the world is that the build team didn't have good economic arguments to put forward to their management to invest into that area. So this blog post, I think, will make it much easier for you to present the business case, right? Why you want to invest into that as an organization.
Exactly, because the people who are on this webcast, they probably are here because they do want to work on this.
Yes.
They signed up for improving build performance, right? But maybe they don't have the case for it yet. And that's just the economical point of view. If I have a frustrating tool, then I get very, very frustrated. So I just lose morale. And I don't want to go to work if every time I have to fight a slow, shitty build, right?
Yeah. And on the other hand, there are people who like that shadow of unproductive tooling to kind of enjoy more cup of coffees a day, and they will tell their friends that they have found a really good spot to work, right? Yes. So it goes in two directions, right? You discourage the wrong people and you encourage the wrong people.
That's right.
So
you really don't want to be in that place.
Yep.
Before we go into the individual points where you can improve your builds, I just have some general advice, and that is first and foremost the process on how you work with performance. It's very important to follow that. You want to start with defining what am I trying to improve. Yep. Don't dive in and change this, change that, just do random fixes from Stack Overflow or whatever, some presentation. Define what you're trying to improve. Like, I'm trying to improve when I do a single line change in this library and then I do an incremental assemble. That's my scenario. I want to make this, I don't know, below 1 second or whatever your goal is, right? You define that scenario, you profile that scenario, and then identify the biggest bottleneck. What's the biggest issue here? Because if you start with the simple things, so you might find a few things where you say, oh yeah, I know how to fix that. But if that's just 1%, then you haven't really gained much for your time. You want to look at the biggest thing.
Yes. Right? And another interesting question: how do you decide what is the most important scenario, right? So and that brings us back to the previous slides, the economic perspective. What is the most frustrating part for engineers? And then you can decide: is it the CI build, or is it the local build? Is it the incremental build? Right? It depends. So and then it would be great if you had numbers. Hey, how many builds are we running locally? How many builds are we running on CI?
And we'll get into that later, like exactly how to find that stuff out, right? So then you do a fix, and now it's very important that you actually verify the fix by measuring again. All too often people do something and then commit, right? You want to measure and make sure that you actually improved the scenario and not made other scenarios worse. That's also worth checking. So once you've gone through that process, you repeat until you're at your target. Right? This is very important. Now, you don't want to go through this manually. You want to automate this process. You want to define your scenarios and then have something that automatically measures for you and profiles for you. So that's why we built this small tool called the Gradle Profiler, which allows you to programmatically define scenarios where you can say, okay, I want to measure how long my clean build takes. I want to measure how long it takes if everything's cached. I want to look at how long configuration time takes as an approximation for my IDE import. So you can just define those scenarios and then tell it, okay, please do 20 warm-ups, 20 iterations, and measure it with JFR or measure it with JProfiler, or all the major profilers are supported. So you can really dig into like where's the time going. And also before you go into little details, it's always worth updating your tools. Like stay up to date with the latest Gradle version, or if you're on Android, get the latest Android version. Look if there's new version for your plugins. Usually they get faster.
Especially right now, right, for both the Gradle Android plugin and the Gradle distribution itself, it's a major focus for us.
There have been immense improvements. So especially if you're on, let's say, the 3.x stream still, there's a lot of goodness for you.
3.x on the Gradle side, right? You mean
exactly, and on the Android side, if you're still on 2.x, I hope not. And then just one word of caution about JVM tuning. I've seen it a lot, especially on Stack Overflow. Just paste these 20 JVM arguments in your Gradle properties and everything will be fine. That doesn't work. Just give the daemon enough heap space and leave the JVM to itself, right? It's pretty well optimized.
And would you also say don't give it too much?
It can reduce garbage collection time, but it's not that important. It's not that critical. But really, I've seen some really fancy invocations of Gradle with 10, 20 arguments, many of which were exotic JVM flags that really made it worse instead of better. You're much better off doing structural improvements to your build than fiddling with these kinds of arguments. All right, so how do I know where the problem is? I've decided on a scenario to fix. How do I find out where that scenario is blocked? There are several tools, but we'll start with the one that is the most user-friendly and the most insightful, I would say, which is build scans. So build scans are a persistent record of what happened in a build, which is shareable. So you can talk about it with your colleagues. You can just paste them a link and say, hey, look, I ran an incremental build and this task is taking so long. Do you have any idea? Or this build failed. I only updated this library and something completely different is now failing. What's the issue here? You can explore, dependency conflicts or changes in dependencies and so on. So it really is a great debugging and collaboration tool. And it also has a great focus on performance, which is what we're going to look into today.
And it's really ideal, if that is possible for you, to share that either with the Android Studio team or with us, because it gives us so much context to reason about where the problem could be coming from.
Exactly right. So that's one of the best things you can send us if possible. So there's like the free version where you can just upload a build scan, which is then, well, it's public in the sense that everyone who has the link can see it. There's no public listing or anything. Or you can get Gradle Enterprise to have it behind your
But from Gradle, so if people don't know, I don't know if you mentioned that, just run a Gradle build with --scan.
Yes.
And you will get a link to such a build scan.
Exactly.
Right.
So we're going to look into the performance aspects of build scans today. And when you click on that performance tab in build scans, you're presented with what we call the build lifecycle, basically. You have a breakdown of where the time was spent. So Gradle executes builds in different phases, you could say. There are different steps. We start up a little command line program that handles your console output, which then connects to the Gradle daemon, which runs your actual build. Inside the daemon, we configure the project. So that's figuring out which tasks are even there, like what are you building, right? And then when we have those tasks, look at which tasks you requested and build the task graph, like which of the tasks we have actually need to run, and then run them. So you get this high-level breakdown of where the time was spent. So for instance, here I had a 200 sub-project Android build that I had generated, and I just called help on it. So with 200 subprojects, it's really dominated by configuring the Android tasks.
Yeah.
So you see about 1.8 seconds of configuration time, for instance, and a 500 millisecond startup time for my command line client.
Yep. You wouldn't get that from Android Studio, right? The 500 milliseconds.
No, exactly.
Yep.
That is the command line client.
Yep.
That's basically
Yep.
zero with
Yep.
Android Studio. You also see how much time was spent garbage collecting. So if that is high, as that
Yep.
goes back to the point about JVM
Yep.
arguments. If you see that most of your build time is spent garbage collecting,
Yep.
your build needs more memory.
Yep.
Otherwise,
And that
this
is, and we have seen that right in the past,
Yeah,
where
absolutely.
80% of the build time was garbage collection.
We saw a
Yeah.
build that was 1 hour and 58 minutes was garbage
Yeah.
collection, and just bump up the memory
Yeah.
a little bit and everything was fine. So we're going to walk through this life cycle, through each of these phases, and look at what can go wrong there. Because Gradle has a very high theoretical performance. It's very highly optimized, and also the Android plugin did a lot of optimization. So if we can get everyone to the point where they are hitting the theoretical performance limit of Gradle, I think that's already a great state for everybody.
Yes. Yes.
But Gradle is also very flexible, so things can go wrong. Plugins can do things that are expensive. Your own build scripts may have problems. So we're going to look into how to find these issues. So there's some useful guidelines that I always tell people to look into to find out, do I have a problem? What's problematic at all? Right? So if the whole startup settings build source that you saw on that earlier slide, if that takes more than 1 second, that's a bad sign. There really shouldn't be much going on there. If configuration time takes more than about 10 milliseconds per project, that's a bad sign. Right? You can't give an absolute number because it really depends on how
Yeah.
many projects you have. But if you multiply that, you have 500 sub-projects, then 5 seconds is a lot.
Yep.
Right? So this is like an upper bound.
Yep.
So if you're above that, you definitely want to do something. If you're at 10 milliseconds, you might still want to do something. There's still room. Another red flag is when a single line change takes almost as long as a clean build. There's definitely something terribly wrong with your build. And so definitely look into that. Do a single line change and compare that to how long it takes to do a clean build. Another very easy benchmark is do no change at all and just run the same task again. So run assemble, do no change at all, run assemble again. Does anything run at all?
Yeah.
Right? If yes, those tasks that are running are a problem because they're wasting your time. Nothing has changed. Right?
Yeah.
And of course, high GC pressure, as we saw,
Yep.
can be a problem. Might be you just need to give more memory. Might be a memory leak in some plugin or some badly behaved tool you're using. Maybe stop using that tool. Maybe report a bug, or maybe there's a new version for it. Okay, so let's step through each of those and see how we might fix issues there. All right, so startup build source and settings is really short and sweet. You want to use the daemon, and you want to make sure it's healthy. You're not restarting it all the time, because the longer the daemon runs, the faster your builds get. As Gradle is based on a JVM, code needs to be just-in-time compiled. So as you run more builds, your code gets more and more efficient. Not your code, but Gradle code and the plugins get more and more efficient. We have in-memory caches, lots of them, that avoid all kinds of file I/O. So if you're not using the daemon, you're paying a huge price. So that's like the one important point. Use the daemon. It's on by default, so you would really need to knowingly shut it off.
Yeah. Since Gradle
3.0.
3.0, right? Yeah.
So, and then there are some pathologies I've seen in the settings file where people, instead of manually listing, okay, these are my subprojects, some people do a tree search, like look for all build.gradle files, and then these are my subprojects, which is convenient, but if you do that, you really want to make that tree walk as efficient as possible. So exclude as many folders as possible. You don't want to look in the build folder. You don't want to look in the source folder, and so on. Because otherwise, you're going to end up scanning your whole project, which is incredibly expensive.
Yes.
Okay, so there's not much more to say here. This is pretty straightforward. Configuration time is much more interesting.
Yep.
A lot of things can go wrong there. So what is configuration time is maybe the first question. It's applying your plugins, evaluating your build scripts, and also running any after evaluate blocks. All of that is what constitutes configuration time. So anything that you have running in there will be executed on every build, no matter which task you run, even if you just run Gradle help or Gradle tasks, or if you synchronize with your IDE, that configuration time will always be there. So if that's 10 seconds, every single one of your builds will take at least 10 seconds. So you really want to get that as low as humanly possible.
Yep.
So one of the most common things that you'll see is resolving dependencies during configuration time, which is bad because when you're not building anything, if you're just calling for help or whatever, or just configuring your IDE, you probably don't need many of the dependencies. So why are you resolving them? And this can happen kind of accidentally. For instance, if you look at this piece of code, what's wrong here? We're just saying, okay, give me all the runtime dependencies and collect them. If it's a directory, use it, otherwise unzip it. Well, the problem is this collect call, because this is happening while I'm configuring the project. I'm forcing Gradle to give me those files so I can call collect on them. So this is like a hidden give me the files, which leads to dependency resolution. Luckily, these kind of things can be very easily fixed. You just make them lazy. You wrap them in a callable, and then you just say, hey, Gradle, I depend on this runtime configuration when I run.
Yep.
And when I run, please go and give them to me, and I'll unzip them and so on. And this is also why I'm not a big fan of these kind of ad hoc tasks, where you just strip something together. We'll see in a moment how that could be modeled.
Right. I wanted to ask about that.
Better.
Right.
Yeah.
Excellent. Because we have a lot of our domain objects are lazy, right? And that because that's easy to get wrong, right? Or you forget the curly braces, etc.
Exactly.
Yeah.
So
but still, I mean, it's still an easy way to solve the problem.
It's possible to fix it that way.
Yeah.
But we'll look at another example. I/O. So what's wrong with this? I have a little task that writes a project statistics file for whatever reason. I want to know how many sources I have. What's wrong here?
The classic.
I'm writing it at configuration time. I'm
Yeah.
writing it no matter if that task is actually running or not. So what did I forget? Well, I forgot a do last block.
Yeah.
And I actually see that in the build scan. I see, hey, my app build script is taking 240 milliseconds. So that's because I'm walking my whole source tree at configuration time. So by wrapping this in do last, I'm only doing it when the task actually executes. But again, I don't really like this ad hoc scripting. Gradle has a much nicer way to do this, which is define a task.
Yep.
Right? Write a task that says, okay, I have sources, those are my input files. I have a statistics file, that's my output file. And here's my task action, that's where the actual code is. So you've basically separated the imperative stuff from the declaration. And then in your build file, all you do is create me a task of this type, and I just configure. Here's the build, here's the stats file, here's the sources. So there's pretty much no way to get this wrong.
Yes.
Which is why I'm a big fan of writing tasks.
Absolutely.
Another thing is inefficient plugins. So plugins that do expensive computations, expensive operations at configuration time, even though they don't need to, or plugins that do it too often. So things I've seen is like network requests at configuration time. There was, I don't know which build it was, but basically there was some code to determine am I in China or not. And the code was let's ping twitter.com, and if we get no response, we're in China. Right?
That's,
So the problem was they got the URL wrong, so they never got a response in no country, and the timeout was 30 seconds.
Wow.
So every single build, they would wait 30 seconds
and then
decide they're in China. But
yes.
that's another problem.
Yeah.
Then they would use the China mirror. So everyone outside of China would also be connecting to the China mirror.
Wow.
So that was pretty terrible. Just use a property for that, right? Just the developer in their user home says location equals China, location equals US, and then you make decisions based on those properties. You say if location equals China, use this mirror. If US, use that mirror.
Yeah.
Easy.
Yeah.
Another issue is plugins that do some expensive computation, maybe necessarily so, but do it too often. One thing I've seen quite a lot is computing some kind of version using Git, for instance. What you'll see is stuff like this. So you have a little script that says, okay, call Git, and then set the output as my version. So I just want to parse the version from the current revision, which is fine.
Yep, absolutely.
It's a way to do it. And then apply this to every subproject. Yeah. Now I have 200 subprojects and I'm parsing the Git version 200 times. I mean, Git is a fast tool, at least in Linux, but still, this is going to take some time. So how can you avoid this? At the very least, only do it once. So have one plugin where you say, I compute this, and then they push it into the subprojects. Yep. We're actually working on ways to model this kind of information so that you could say, actually the version is a property that can be calculated lazily. So the Gradle APIs and plugin APIs will evolve so that you can model this kind of thing and say, I don't have a string right now, I don't have a version string right now, but I will have one later if you call me, and then I'll call Git. And if I don't need a version for my build,
I don't even calculate it once, and otherwise only once.
Exactly.
And that's with the provider and properties.
The provider API, which we're slowly rolling out to more and more tasks. Exactly. So that's going to become the standard throughout all Gradle APIs, that you can do things lazily.
Yeah.
Okay. There's one more thing that's kind of Android specific. I just want to mention that here, which is in Android you have this concept of build types and flavors. So you can have different versions of your application depending on, am I building a debug version, a release version, a QA version? Am I building for ARM or x86? Am I building for free or paid? This or that target audience, right? And this can quickly explode. The worst we've seen was like 400 variants in a single project.
Imagine.
So that means a lot of plumbing that the Android plugin has to do. If for 400 variants, they need to create, I don't know how many tasks for each variant. So it ended up with like thousands and thousands of tasks to build that project. And when we actually talked to that specific customer, what they found was, well, many of those combinations didn't make any sense. So like we never ship a debug version to that customer, for instance. Right? So just slash that in half. You know, like just remove all customer-specific debug versions and stuff like that. So there's a variant filter API in the Android plugin where you can say, if I have this build type and this variant, this flavor, don't create a variant for that because this combination doesn't make sense. So really think about what combination. Would you really ship 400 different apps? Probably not.
Great.
Exactly. So that is configuration time in a nutshell. Avoid I/O. Avoid network traffic, avoid dependency resolution, and avoid doing things again and again.
There is some stuff we are working on, right? That are on the that are close to being rolled out.
Exactly.
Do you want to talk about that?
We can have a quick chat about that. So on the very bleeding edge right now, we have what we call lazy tasks or lazy configuration, which allows you to say, okay, I'm going to have a task here, and if I need it, this is how it's configured. Which really, if you look at the Gradle DSL, you say task, foo, and then you have this closure. It kind of suggests that that's what happens, right? The surprising thing is that this was eager at all.
Yes.
Well, it's history. We have to live with that, but we're moving towards an API where you say, here's how you can configure that task if you need it. And then all these arguments about the variant explosion, for instance, become much less of a problem.
Exactly.
We can create thousands of placeholders very quickly if we don't go and configure them. Right? So that will also shape a lot.
And the good thing is those improvements, right? We will apply them, and we have already, right, to the internal Gradle plugins. The Android plugins will pick them up. So even if you don't use it for your own plugins immediately, right, you will already benefit from those improvements.
Exactly.
If you upgrade to the latest version of Gradle.
We did it for our own build. It already resulted in about a 25% improvement. I mean, our own build was already highly optimized in that regard. So 25% is actually a lot for us. We tried it or the Android team tried it with the Android plugin. They got to like 95% lazy configuration, and then use that on one of our example projects, this 150 module project. and it cut configuration time in half.
In half,
So
yeah. And it doesn't have a crazy amount of variance even, right?
That doesn't,
project.
yeah. That's
cool.
So that's going to be really useful, especially if you have lots of variance.
Yeah.
Those are like the bottlenecks at configuration time.
Before we get into the next topic, so the classic question, do you recommend using the Gradle daemon on a CI server?
Yeah, no problem. I mean, there are plugins that have some issues, but I think it's good to slowly push them. Because if you have throwaway machines and you only run one invocation of Gradle, then the daemon doesn't help you.
Yep.
But if you have longer lived agents, and like we do, we have persistent agents that run thousands of builds until they are restarted someday, and the daemons on those machines run thousands of builds. So that saves a lot of time.
And it's running very reliably. That is not a cause for us of flakiness.
We've had like one community plugin which had an issue.
Memory issue, leakage?
I think it was a memory leak. But we're in contact with them fixing that. So and that's really what we should do. Yes, you may end up with some problems if you're using a community plugin that's badly written. But then it's the good thing for the whole community if you report that instead of just switching to no daemon. Right?
Yes. And the only other thing I would say, if you build many different projects on CI with different JVM arguments, then you might get an explosion of daemon processes. Right, so that was the only thing I would...
It depends. The question is really like how many different daemons will there be?
Yeah. So if you would end up with 20, 30, 40 daemons, then...
But if you have one machine that is responsible for building 20, 30 projects, then it probably also has 30, 60 gigs of RAM.
Right. Yeah.
And that's not an issue then.
Yeah. Just be aware of that, right? That when you have different JVM arguments for different builds, right, then that will create different daemon processes, and then just check if it's working. But the daemon is stable. It's not a. That is the key thing. It just needs to have enough resources.
Yeah, it's not some fancy optimization with that you should only do locally. No, it's really the heart of Gradle, and it really helps with cache builds. Like if you're using the build cache and all your tasks are actually coming from the cache, which happens a lot for us. We just change one sub-project, everything else comes from the cache. Then we're saving a lot of build time by having warm daemons that can immediately tell, oh yeah, that's up to date. Instead of, starting up a daemon, reading all the file system state back into memory.
Yes, absolutely. So we have two other questions regarding to memory. I think they're easy to answer. What's the time limit for GC time? And the other is, if I add more RAM to my laptop, can I make the build faster?
Okay, what's the time limit for GC time?
I guess what they're asking is, what is a good recommendation?
No significant time of your build. I mean, if you have a 1 hour build and 1 minute is spent in GC time, it's probably fine. Yeah. If you have a 1 minute build and 50 seconds is spent in GC, that's really bad.
So it's all about the percentage, GC time versus build time. Exactly. If that is too high.
Like the GC overhead should stay somewhere in the 1, maybe 2% range.
Yeah, perfect. And then the other question, if I add more RAM to my laptop, can I make my build faster?
Depends on how much RAM your laptop has. Right? If you're at 2 gigs, then yes, absolutely. Yeah. But it depends what else you're doing. It's usually not a single build that's the problem. It's usually you're also running IntelliJ. You're also running Chrome with 400 open tabs. So yes, I mean RAM makes everything faster. So.
Yes, but at one point it will not, right? And then if you look at the build scan, if you see a lot of garbage collection, give it more RAM. If garbage collection is fine, then more RAM will not help you.
More RAM might help reduce contention with other processes, like paging.
Right.
But otherwise,
Then we have a question. Gradle help 8 modules takes 15 seconds.
No, that's not normal.
That's not normal.
Definitely go measure.
Yes.
There's something very, very wrong in that build.
This presentation is for you.
Exactly.
So let's continue.
Okay. Let's talk about writing your own build logic. So we've talked about community plugins. There's not much you can do beyond tell them that there's something wrong. Let's talk about your own logic. One thing you want to do is structure your build logic properly. Don't have like one build script with hundreds or thousands of lines of code with ad hoc tasks and ad hoc wiring and lots of imperative code, because that's a pain to read, and it also won't give you much insight into where the problem is, because a build scan will only tell you, well, the problem is somewhere in those 2,000 lines, right? That's not helpful. So split things out, break them down into smaller plugins. You can do that with scripts, or we call them script plugins. So apply from this.gradle, that.gradle, which already makes finding issues easier. So if you look at this example here, you have the environment.gradle and the version from status.gradle. The build scan will tell me that version from status, for instance, that we saw earlier, was the bottleneck because it was executing on every subproject. So it made it much easier to pinpoint what the problem was. If I had just inlined all that code in this one script, I wouldn't see anything. Right? But even better, and what we're moving towards more and more, is extract things into build source. This has always been a recommendation. Write proper binary plugins, so write Java classes or Groovy classes with compile static, or Kotlin, or whatever your language preference is. Use a statically compiled language, because that really speeds up things. Dynamic invocation is expensive. And this really helps keep build scripts declarative. By having the plumbing, the imperative code, like create another source set, its class path should be this, and I need to take the result of the main compilation and wire that in and so on. And this low-level plumbing, that belongs in plugins. Your project should just say, I am such a project with integration tests, and maybe here's where my integration tests are located. Right?
Yes.
Keep build scripts declarative, put the imperative stuff into plugins.
And I want to add one thing here, to be fair, right? One issue was always tooling and IDE support for properly refactoring a build logic. You could do all that, but the tooling support was not very good, right? So you refactored something in build source, it was not reflected in the build script, and so much has improved in regard to that over the last 6 months, so particularly with the Kotlin DSL. Right. So
the Kotlin DSL actually takes this to its logical conclusion. When you use these what we call script plugins in Groovy, in the Kotlin DSL, those are actually just scripts in build source. So that the new conventional location is in build source. They share the same class path as any other plugin in build source would have. They are precompiled. And they behave just as if you'd had written a Kotlin class.
Exactly. So and still super convenient, right? So all the overhead you had in the old days creating binary plugins. I mean, it's always a bit of overhead, right? It's gone with that mechanism, right? Because you just have certain conventions for
you don't need to declare a plugin ID. It's just derived from the file name. You don't need to create like the class body. It just removes a little bit of noise.
But which often makes the difference for people that are busy with other stuff, right? So so definitely check out Kotlin DSL. That makes that approach extremely convenient, right?
Even if you're on Groovy, we've seen lots of customers just taking some of their scripts that were doing low-level plumbing and converting them to plain Java or Groovy with compile static. Immensely improved the configuration time because they got rid of all that dynamic invocation, and it made the build more readable. So it really helps. And then at some point you might get where there's something wrong with one specific plugin, either at configuration time. It's supposed to run, but it's too slow for what it does. So you want to optimize at the algorithmic level. That's where build scans kind of stop. They tell you at the domain level where the problem is, so in this plugin. But when you need to go deeper, you can use the Gradle profiler again, which also has profiling options for all the major profilers. So here I used JFR, for instance, and we have this nifty tool that converts the JFR output to a flame graph. So the Java Mission Control UI is not the greatest, unfortunately. It's hard to see bottlenecks. With those flame graphs, it's super easy. So what's in that screen is really a well-optimized Android build, because you just see a big tower of creating Android tasks. So this is the Android plugin doing this work. And this will almost completely disappear once they're lazy, once they're lazy tasks. So this build here would probably lose 60% of its CPU samples and get 60% faster configuration time, if CPU is the only limiting factor. Right? So this is really helpful. It shows you CPU, it shows you memory, I/O, and so on. So when you need to dive down, Gradle profiler is really, really helpful as well.
So before we come to execution, a couple of more questions. So while using daemons in our build server, we've seen the server fill up with daemon logs. Is there a good way to clear those logs or have them expire? We have the daemon disabled to prevent this currently.
Just delete them. Like, they're in a conventional location. Right now, you'll have to delete them yourself. It's my recommendation. The Gradle object gives you the location of the home directory that you're running with. So just clear out that log directory every now and then. Sorry for that. we'll add some housekeeping.
So as part of the cache cleanup, the new feature, this will not be those will not be cleaned.
Those will not be cleaned yet, but it's just logical.
Yes.
I totally agree with that user. This shouldn't happen, and we will fix it. But for now, you can just delete all files there yourself.
Cool. Yeah. So on slide 30, you had a perfect example of an expensive operation that was being done for each task. Call out to the command line and collect data to be used for all tasks.
Yeah.
Even though it needs to be just done once. What is the actual solution to that? I need to solve this use case and I cannot find an example of how to do this. So we talk quickly about it, maybe
so
mention it one more time.
That is exactly what the provider API will be there for. So today, like if you have a traditional Gradle with just normal Java Bean properties, today the way you do that is you run a task which then pushes that configuration into the other tasks. So what we used to call a configuration task. Right. And so you have the tasks that need that piece of configuration. They all depend on one task that reads that configuration for them and pushes it down into them at execution time.
It pushes it, or it gets pulled from the other tasks?
It pushes it.
It pushes it.
That's like the old...
So it configures the other tasks.
Yeah, it configures the other tasks.
So it says, hey, all projects or sub-projects, and then iterate over all the tasks and inject the value.
That's like the unfortunate
it's a solution.
But where we want to go is exactly this provider API where we say, here's a provider that computes something, and then push that into the property of each of those tasks at configuration time. And just say, here's where you get your value from when you need it. And then those providers will eventually be locked on first read and memoized, so they only compute once.
Yes.
For backwards compatibility reasons, right now they're called every time, but this will change. This will definitely change.
Good. So how do I figure out why my build.gradle taking 800 milliseconds to configure, as in what part specifically causing it? We already mentioned that, right?
You can use build scans to get a feel for like which plugins are causing it. If you want to get lower, if you want to know, it's line 34 in your build script that's doing some file I/O or something like that, then as I just showed with the Gradle profiler, you can use JFR, you can use, if you have licenses, you can use JProfiler or YoKit, right? And really dig deep.
Is the Gradle daemon shared between projects with different Gradle.properties, or should I try to unify my property file across projects?
Depends on the properties. So there's a few properties that are important for the daemon, like the amount of memory. If a daemon has 1 gig and a project says I need 2 gig, then we can't use it. Right? If it has 2 and the project needs 1, that's fine. And there's a few other properties like the file encoding, which we can change once the daemon has started. Most other things like Gradle properties are no problem. They're just sent to the daemon and changed. Most system properties are mutable, so except for user dir and stuff like that. So most system properties are changed to make the daemon work for your build.
So the simple answer is, besides JVM args, right, they need to be unified with, although we have even some leniency there, if we need,
within reason.
And otherwise, it doesn't. You can have different
Gradle properties themselves are no problem at all.
Last question: can you use Gradle build cache with multi-dex enabled true, set to true?
Well, you can. The dexing is not cached at the moment.
But that's something
that will change.
We're working on, right?
So execution time is, as the name implies, when the tasks that you selected are executed. And there's 3 main ways that Gradle makes this fast, which is it executes tasks incrementally, it caches task outputs, and it parallelizes tasks. So let's look at these in turn. So incremental builds, as I said at the very beginning, if you didn't change anything, you run the same task again, and anything is executed, there's a problem. So here I have a timeline of a build scan where I was just running assemble dev debug on an Android project. I hadn't changed anything and I ran it again. Pretty much everything reran. It was almost as slow as a clean build. So in the build scan timeline, you can click on the task and see why it ran. So I looked at it and saw the value for the input property version codes has changed for process debug manifest. Now, you need to know what version codes mean. So some domain knowledge factors in there as well, right? So it happens that I knew version code was being populated by somebody setting version code equals new date. So just adding a date down to millisecond precision. So every build is different.
Yep.
That completely destroys incrementality. Don't do dates. Or like, well, I mean, if you have to do the current day of the year, or what you can also,
or depending on where you use that information, right?
Yeah. So do it only when you release. Like,
yes, exactly.
You don't need that for debug builds.
Exactly.
Right? There's another common one, which is Crashlytics. So Crashlytics, it's kind of inevitable, needs a unique ID to identify which of your app builds was causing a crash. And you want to know, okay, this release has caused this crash.
Mm-hmm.
So you need an ID, but the problem is it actually activates this by default for every build, even local developer builds, where this really doesn't make sense because you're testing on your phone. There is no question what you're testing. It's what you just built. So you don't really need this unique ID. Unfortunately, it meant that on every single build, as soon as you applied the Crashlytics plugin, you would always get out-of-date tasks. You would always get full recompiles. So this is one of the few snippets that I recommend just pasting into your build, basically. And the Crashlytics team is aware of this, so we've talked to them, and they will work on a better solution to fix this. Because this is also happening on CI builds. Not every one of your CI builds needs a unique ID, right?
Yeah, and it kills the cacheability as well.
It kills the
so it's not just the up-to-dateness.
It's not just up-to-dateness, it's also cacheability, because this build ID is also part of the task's cache key.
Yeah.
So they're aware of it, they're thinking about ways to solve.
Cool.
And maybe only have like an option to say, only create a unique ID when I'm doing a release or something like that. Gradle provides lots of ways to make a compilation faster. We have, for instance, the concept of compile avoidance, which is when you change a class in project A and you only change some method body, so some implementation detail that isn't exposed anywhere, and then project B depends on this, project B won't be recompiled because none of the signatures have changed. So from project B's perspective, there's nothing to recompile. So modularization helps get this compile avoidance. So compile tasks won't run at all. There's also incremental compilation. So within a source set, we can actually tell, okay, you changed this file or you changed this upstream class. Who depends on that? Who's affected by this? And then just recompile those. So like you change class foo, and then you have class bar extends foo. If you change foo, we're going to recompile bar as well. Incremental compilation really benefits from nicely decoupled code. Now, if you have spaghetti, everyone referencing everyone, then incremental compilation doesn't help that much.
Yeah.
Because, well, you know, it could put, like any change could potentially make everyone break everyone. So if you basically good software engineering practices not only give you code that's more fun to work with, it also gives you faster incremental compile as a bonus.
Absolutely.
And then there's one word of caution, unfortunately. I know everybody's really, really excited to start working with Kotlin, and I mean, we're working with Kotlin as well, and we're fully on board. But there are some issues with Kotlin at the moment. Most importantly, Kotlin annotation processing. That is unfortunately very slow. So you want to avoid this at the moment if you can. Like use Kotlin language mechanics, Kotlin libraries to save lines of code instead of using annotation processors, which are more a Java ecosystem tool, right? So for most annotation processors in the Java world, there's actually an equivalent Kotlin library that does the same thing without any processing, just using basic Kotlin language features. So you get the best performance if you separate your Kotlin code and your Java code in different subprojects, and when you're doing the migration, really splitting out pieces of your Java code into their own module and then convert them all, splitting out the next piece.
So the problem, just to be clear, as soon as you have mixed code, right, and one annotation processor is used, even if it just applies for the Java parts, it will
get significantly slower.
Do we have example numbers?
So what I did was I took a 500 module, like our canonical Java enterprise example, which is like 500 modules. Every module has 100 source files. So, and it's like total of 5 million lines of code. And that project usually compiles, like clean compile in 30 seconds. And then I applied the KAPT plugin. I didn't write any Kotlin code, just applied this Kotlin annotation processing, and it went up to 50 seconds. So 60% slower, right? So that's the current problem.
We're working
but we're working
intensely right on fixing this. This is not
it's a temporary
inherent basically quality right of Kotlin and negative quality.
There's nothing fundamentally preventing Kotlin from doing this faster. It's just work. Exactly. So try to split basically pure Kotlin, pure Java. It's the best way to do it.
To have good build time, fast build times.
And then there's also the other elephant in the room. It's not the Gradle friend. Whenever I say incremental compilation to people, they say, well, yeah, but you deactivate it as soon as I have an annotation processor. And that is for good reasons, because we don't know what an annotation processor is. Just some piece of code. It's a plugin that runs in the compiler. It could be formatting your hard drive for all we know.
Yes.
Right?
Yes.
So, but we needed to do something about it. So in Gradle 4.7, we added this feature called incremental annotation processing, which is an opt-in for each processor author. There's a set of rules that they need to adhere to. So there's actually no additional API. It's all purely based on the existing Java, C processing APIs. It's very low, very unintrusive. But they need to adhere to some rules, like you can't use side channels. You can't do like Java I/O and just write something. You can't do network requests and get something that we don't know about. But many processors fall into this well-behaved category. Right? So they can now opt in. There's a single line of resource file where you say, I am this kind of processor. And then they will actually be run incrementally. So
that makes a huge difference.
That makes a huge difference.
Especially for the single line of code, obviously, scenario, right? So for all the Android Studio users, right? So we now provided a mechanism, I think a really simple mechanism that would work for most annotation processors out there.
Yes.
Now we require them to basically do this little change, right, and provide us with this information.
We need help basically. We have some early adopters. So Project Lombok, for instance, already jumped in. So Lombok is now incremental, which is great.
Awesome.
Android State is another small annotation processor that is used in the Android ecosystem. They were the first ones. The day after the Gradle 4.7 was released, they were on board. And then we have a list in this issue that's linked here of all the processors that we know that are popular. So we just asked our user base, tell us what are you using, and a link to the issue or pull request. Where there's a discussion about that. So you can help us. You can tell the processor authors, hey, here's how much this is bugging me, or I'll test it for you. I'll write a pull request for you. Any kind of help is really appreciated there.
And one thing we are working on, right, is to expose how long actual the time is spent on a particular annotation processor. So that is coming over the next months probably.
Yes,
and then in build scans you can see that, and then it gives you even a better idea about the price you're paying for that, right?
And sometimes that there might be a processor that really doesn't want to opt in, or is badly written and just doing really weird things that prevent it from opting in. Then you might really want to look at that data and see, on every single build I'm losing a minute of my life.
Yes.
Is this really worth saving 10 lines of code? It's a trade-off. Like annotation processors are great tools, but they're not free. So we're trying to make them as cheap as possible. But they need to help us. All right, so let's move on to caching. So caching is basically the next higher level when we can't run a task incrementally. Let's say we don't have any previous state. We're on a CI server, we just did a clean checkout. Or you switched branches, a different Gradle version. We still can avoid running the task using the build cache. So what the build cache does, it basically creates a fingerprint of all the inputs of a task and then looks up in the cache, have I seen this fingerprint before? If yes, take those outputs and put them into the output directory, don't run the task. Very simple mechanism, very powerful. It saves us immense amount of time on our own CI pipeline because we have this huge fan out of builds for every part of Gradle, and not every part is affected on every change, only a few are. And this saves huge, avoiding compilation, avoiding tests.
Avoiding testing, that's what many people don't see. If you have let's say, a 30 submodule, even a 10 submodule build, right? At the moment on CI, you run the test for all those 10 submodules. But if you only change one submodule, and then the other submodules that don't depend on that submodule doesn't change, you will not need to rerun the test. Gradle says, test input hasn't changed, so we just retrieve the test output reports, right, without running the test. It's huge. Right?
It's huge. It's saving us countless days of developer time. So
and there's work, right? So a lot of the core plugins, the cacheability is now really good. I wanted to mention a couple of things. So if you have custom plugins, custom tasks, first of all, regarding the annotation processors, use this for your custom annotation processors. We know there are quite a few companies out there to make them incremental. Caching, the same thing, right? We have really good guides regarding how to make your tasks cacheable. And on the Android side, there are a couple of complex tasks where we decided not to make them cacheable now, because in some scenarios that would add overhead, although in other scenarios you would already benefit from that. And we are now working on getting rid of the overhead for those scenarios, and then particular dexing, we will enable the cache out of the box.
Exactly, the dexing and the sugaring and all those cases that are currently not cache enabled, they'll all be cached eventually.
Great.
So in the build scan, you'll see, okay, is my build cache enabled at all? What's my hit percentage? Are there any errors going on? Right? And just as with the incremental builds, you can dig into each task and see what changed, why did it not come from cache. You can compare across builds and see, okay, I expected that this build should have been fully cached because I built the same thing earlier. What changed between the two? Oh, I have some timestamp.
Exactly.
Right.
Exactly. So, which is so hard otherwise to figure out. Or it might be you wonder why is never anything cached in the Bangalore office, right? There might be some specific setting for the local, right? That you can never reproduce locally with your build, that only invalidates the cache always in that particular environment.
Exactly.
Right?
Or like they're getting cache hits, but it's super slow. Oh, right. Our cache node is in San Francisco, so of course it's super slow for them. So replicate to their office. All right, and then last but not least, parallelism. Historically, Gradle comes with the -- parallel flag, which what that does is just saying, assume it's safe to run tasks in different projects in parallel, and that's a pretty reasonable assumption. Like, it works for most projects, but it's not strictly safe. Like, if you have multiple integration tests in different projects accessing the same database, that wouldn't work. So parallel wouldn't work for you. But we're working on an API, the worker API, which actually allows safe parallel execution of tasks. So tasks opt into this, and they're completely isolated. They can't change any shared state. It's really a very safe API. What can be done in process, out of process, etc. And then these tasks just parallelize automatically. So what you'll see in a build scan is if parallel isn't enabled or none of the tasks use the worker API, you'll see something like this, just a long serial line of execution. On the other hand, if you switch on parallel, you'll see, okay, a lot of stuff can actually be done at the same time, and you'll also see your critical path, usually very clearly. That, okay, I have, like in this Android project, I've done some effort in modularization. I've split out a few things. Those libraries are being built in parallel, that's all cool, but the majority of my code is still in the app, and so I still have a very long step where I'm building my app. And also there's some Android tasks like resource merging right now that are not very well parallelized, but the Android team is completely changing that pipeline. So this will soon be highly parallelizable as well. So, and again, if you're writing your own tasks, use the worker API to make them auto-parallelizable. Right?
To be fair, there are still some limitations with the worker API, but for many tasks, it will work fine.
It works for many things. There are some, I would even call them inconveniences. Like there's some things that are not super convenient to do, and we'll fix them. But a lot of people are already using it, and it works really well.
Right. So should we go into the question now?
Let's talk about execution time or whatever we have in terms of questions.
So unit test fails randomly in multi-module project when parallel equals true. If no parallel is added, all tests succeed, but this is time consuming. So
I mean, unit tests failing randomly, make sure there is no dependency between them. Maybe they're mutating. Actually, they must be mutating something on the system. Like, make sure they're not using any folders that are shared or connecting to any databases. Or it's hard to tell from this information. But if your unit tests fail in parallel, that means they're doing something that depends on the system state.
So, and that is something we need to you need to dive into. There's no way a build system can solve.
I mean, what we will do in the future is give you a way to say, okay, I mean, unit tests really shouldn't do this, like anything that requires shared state, right? But integration tests often do that. You know, there's definitely use cases where you have, okay, I have this shared database, and there are ways to make it possible to run tests in parallel against the same database, but it's much harder to write them. Right? You can never do stuff like I expect this table to be empty, or like it just doesn't work.
Yes.
You always have to do like unique IDs and stuff. So what most people do is just they don't make them parallel safe. So what we'll provide in the future is some way to say these two tasks both require that database, this shared resource.
Yes.
Don't run them in parallel. Right?
So what could we recommend to make dash parallel work in such an environment? Bundle all the tests that require that resource maybe into a separate sub-project where they run as one test execution, or what do you think?
It's a good question. There are ways to, like hacky ways, to prevent parallelism by locking, but then you're eating up worker processes basically.
Yes.
There's really no good solution. Like if you have tests like this at the moment, you could shove them all in one sub-project, but there's really nothing else much you can do right now.
So that would be one thing, so get them all in one sub-project, the ones that can be run in parallel. The other would be at least to have some switch. If tests are executed, disable parallel, otherwise enable it. Is that something?
You could.
Then you at least in Android Studio, right, you would still have what do you think?
You could do that. I think really we need an API for you to say but these few tasks are not safe.
We encounter log error when multiple builds are running at the same time. For example, download artifacts. Is there a way to fix it? Or for users to configure the log policy? This could block container deployment for Gradle. That was the container question.
Okay, so if you're running your builds in containers, you can't share the Gradle user home. Like this is not meant to be shared because the log contention mechanism is based on socket communication, and the Docker containers can't talk to each other. Also, you'll end up with funny behavior like the daemons shutting each other down because the client will try to connect to a daemon because it sees it in the registry in the user home. But actually that daemon was in another container, it can actually connect to it.
Exactly.
So it'll say, oh, that daemon looks like it's dead. I'm going to remove it from the registry. And then the next time this daemon looks in the registry to see, oh, I have been removed, that probably means I should stop myself. Right?
So what do we recommend here?
Well, don't share the Gradle user home between Docker containers right now. Use an artifactory that's close to your build servers so they can just quickly download the dependencies into the container. Don't share the user home.
So we are working on a solution to give you nodes, right, on the machine, right, where you can cache your dependency. So we are aware of that problem. We're working on solutions for that at the moment.
But right now, really, it's just don't share the user home between containers. You can it's fine. Like you can have as many daemons as you want on the same host, in the same container, basically. Using the user home. But if they can't communicate with each other, then it doesn't work.
With the question, we have 650 modules and configuration times hurting builds a lot. 30 seconds each time on MacBook Pro. Already optimized. What could we do on our side?
Well, already optimized. I mean, have you looked with the Gradle profiler where the bottleneck is? Send us the JFR recordings.
We're super happy. We love to learn from those builds. Right? There's always something for us to learn, and we can give a lot of feedback. So send an email to Stefan@Gradle.com or Hans@Gradle.com.
We actually have performance@Gradle.com.
With performance@Gradle.com.
Everyone interested in performance will listen to you.
Excellent. So is that a Google group or?
Yeah, it's an internal email alias.
Okay. Got it.
But so you can just send JFR recordings there. They're confidentially handled by us, and then we'll look what's going on. So just use Gradle profiler --profile JFR with 30 seconds. You probably need maybe a handful of warm-ups, a handful of iterations, and you should have enough data for us to tell you, here's something you can do, or here's something we can do.
Yes, absolutely.
30 seconds is completely unacceptable.
Yes.
I fully agree. That should be analyzed.
Great. Lint tasks takes a lot of time to execute. That's for Android, right? And also runs when I did not change any code. Is this expected?
So it's expected that it takes very long. Lint, unfortunately, is not well optimized. And the Android team, again, is aware of that. And there will be changes in the future, but it's just, yeah, they have a lot of other things to do as well.
And I think lint is not cacheable at the moment, right?
It's not cacheable, and yeah, it shouldn't actually no, it also doesn't declare inputs, so it will always rerun.
Yes.
So it's really, yeah, try not to run it if you can.
Yes.
If you can help it. It's
at least for define certain flows in your Gradle build where you don't need it, and CI is nothing you can
like
do.
on local developer builds, probably don't run lint. And on CI you can't avoid it, unfortunately. Yeah. Sorry, there's really not much more we can say here. The Android team will fix it eventually.
Yeah. I don't see JPA model generator as an incremental annotation processor. Do you know if anything is being done here? Well, just add a comment to that issue.
The JPA model generator is not an annotation processor, actually. It's a bytecode instrumentation tool. So it's a different way of doing things. It's not annotation processing. I think the Eclipse Link model generator is an annotation processor, but the JPA one is a bytecode enhancement tool. So it basically runs after the compile step.
Right.
And yeah, that one is also not incremental. But so they could change to be an annotation processor, or they could change to be a Gradle task that runs incrementally.
That's what they.
Those are their options. Yeah.
Okay. I'm more than happy to advise them.
Yeah,
of
course.
Right.
If they wanna advise on that,
it's easily solvable in that case.
I think so.
Yeah. We're probably right. Yes.
We are not JPA experts. There's probably 1,000 corner cases. But
are the annotation processors cached by default? Is there a good resource to optimize my process and avoid generating my classes if the annotated class has not changed?
Did you mean cache or
cache by default? So first is the question about caching.
So the Java compile task is cacheable no matter if you have annotation processors or not.
So yes, caching is enabled and will work.
Yeah.
We could also talk about compile avoidance and annotation processors, right? Because that you use the right annotation processor.
But that's with 5.0, there's just no other way anymore.
Yeah, but people are not on there yet, so that's another thing to keep in mind, right? That they provide the correct annotation processor class path, and then is there a good resource to optimize my process and avoid generating my classes if the annotated class has not changed? So where can they just Google for incremental annotation processing?
In the Java plugins documentation, there's a chapter on incremental annotation processing.
Excellent.
And you'll find it's a very short description because there's really not much to it. Like if you understand the constraints and you can guarantee that your processor fits those constraints, you're not doing any out of bounds stuff, then you can opt in and you're fine.
In Android, there is bad practice to keep static references to context objects in Android classes. Google states that it breaks the instant run feature. I would like to know if that also slows down the build process.
The build process probably not. I mean, static state is always a problem in terms of incremental compilation because it usually means that there's also a lot of tangled code, like there's lots of references to that state if it's public. But otherwise, yeah, this is mostly a runtime issue. So, okay. Let's assume you've spent some time, you've really optimized the hell out of your build. How do you make sure that it actually stays that way? and how do you find other issues that you might not even know about? So that's where Gradle Enterprise comes in, which is basically a tool that allows you to see all the build scans of all the builds that happened in your organization, not just on CI, but also local builds. You can search, and there's a nice performance dashboard, so you can really see what's going on in my organization. How long are things taking? What's the average configuration time? What kind of tasks are people running? What kind of tasks are usually failing? And so on. For instance, what I looked at here is, give me local builds where somebody requested clean. Now with Gradle, you should pretty much never have to run clean, because it has rock solid incremental builds.
Yes.
So there might be an education problem. It might just be someone who comes from Maven, where you're completely used to always calling clean.
Yes.
So maybe I just need to call this colleague and say, hey, did you know? You don't need to do this. You can save a bunch of time for yourself. Or maybe this colleague discovered a bug in one of our tasks that we've written that doesn't behave correctly incrementally, and they didn't call me as the build engineer. They're just frustrated and just keep calling clean, right? So this makes it very easy for me as the build engineer to find out without needing people to tell me, just to find out, oh, okay, maybe there's something wrong. So I might look at the build just before that colleague started using clean all the time. Maybe there's a failure there. Maybe I can already learn what the issue is. I should look at that task, right? So this really helps. collaborate and find out issues. Of course, for every one of those builds, you can click and you'll get the deep insights that we talked about in the beginning, get the performance breakdown. And also, you get a really cool performance dashboard. So this is actually our own from a few weeks ago. And this was something that bothered me. The configuration time had gone up like crazy. I was like, whoa, what happened here, right? And then I investigated some of those build scans and I found out those were from all the people who were converting Groovy build scripts to Kotlin build scripts, which is what we did a few weeks ago. And we had a lot of build script changes. And then yes, if you change build scripts and the Kotlin compiler needs to compile the new build script, then you get lots of churn in the configuration time. So this was normal, this was expected, this was fine. But if I see such a spike when we don't have such a refactoring going on, then I'm like, oh, wait a second. Right? There's something wrong here. We need to look at what our builds, what has changed lately. And there's an export API. You can export this to any kind of business intelligence tool and graph to whatever insights you need, right? Graph this and have an alarm in your in your build master's room. So this is how you find out what's wrong and how you make sure it stays right. Okay, so I just have a few resources. We have a really nice performance guide that explains a lot of the things that we just talked about. The Android team has written a performance guide with Android specifics, like the Crashlytics issue, for instance. We have a plugin development guide that discusses performance aspects of when you're writing your own plugin. So that's very interesting for build engineers, but also for plugin authors, for community plugins.
Absolutely.
And then we also have the organizing build logic chapter, which talks about, hey, how do I organize the logic in my builds? How do I break down build scripts into smaller things, into plugins? All right, and of course, if there's one thing to take away, go to scans.gradle.com and start using build scans for your projects to see, like, on a high level, where the time is going, right? Try it out.
It all starts, first of all, what do I want to improve, as you said, and then get the data and then get the insights. There's so much speculation we see in organizations about what makes the build slow. Is it the IDE? Is it Gradle? Is it this? Is it that? And it is really, it's frustrating because you have to penetrate, right? We have to, and it all starts with data and insight.
Exactly. It always starts with scans, and then you might end up with a point where, like, okay, plugin XYZ is adding 5 seconds to configuration time. That's the moment when you fire up the profiler with JFR and look at the algorithmic level, what's that plugin doing, right? But the first step is always the high-level overview in the scan.
So we have a question.
So we have lots of questions.
So is there a way to share a Gradle Enterprise scan with third parties? Currently, you have to remove the set server config and rerun the build, so I can share it when reporting issues. Yes, there is a way. So you can get a dump of the JSON file, and you can send that to another person with Gradle Enterprise. They can import it and then look at it. So, but this other party would also need to have a Gradle Enterprise instance.
That's right. It's an undocumented feature at the moment because it has some usability quirks, but so it's under admin upload dump, I think. Where the other party can then upload it into their own enterprise instance.
So if you're using Enterprise, just use the support you have with Enterprise and ask the question, and those guys can help you. Another question, we need to call clean often, otherwise their compilation errors might be connected to Realm, but still.
Yeah, well, you need to find out what's causing the compilation errors. Like, is it, I mean, first of all, Realm is an annotation processor. So if you have an annotation processor, we won't do incremental compiles at all. So
but they still say they have to do clean, even in that case. So
that's really weird.
That's really weird.
You'll need to dig in a little deeper. Like what
it could be stale output stuff, right? If they,
I don't know, what is causing the compile error? Like in which module? Does that module use Realm, or is it maybe something different, right? So I mean, if you have an example project, if you can boil it down to something that we can look at, then
otherwise it's impossible to answer. In general, right? Something is wrong. There is a bug if you have to run clean, and the bug is likely not be in the Gradle core.
It's unlikely. It has happened, but
of course, right. So
it's getting much less common. It's usually some third-party tool that doesn't behave well.
Then we have a question. Interesting question. Cache only works if we use same machine to build. Correct?
No. That's not correct. That's the whole point of the remote cache. So
there are two caches, right? There are two build caches. One is local, comes with Gradle, but you can also install a remote cache to share a build output.
Exactly.
Right? And that brings us to the next question. If you do that, we have the question by default. Check style seems to contain all those HTML references which are absolute paths. So it breaks cacheability. Can it be fixed?
Probably.
So does our cache style do that? I don't know.
So I wasn't aware that there was a problem with check style.
Yep.
I mean, we use check style ourselves, and we don't have cacheability problems. So open a bug with a project that shows the problem, and yeah, we'll look into it.
What's the recommended language to write custom Gradle plugins, and why? Java or Groovy is the question. Right.
Whatever you're more comfortable with. If you use Groovy, definitely use compile static.
Yeah, and then of course there is now the third option. Kotlin. And the release candidate 1 has just been released, Kotlin DSL 1.0. So we expect a GA release soon. Exactly. And then there's a Kotlin migration guide, so read about it if you're interested. But the key thing is statically, I mean, there are a couple of things.
You could use Scala.
You can use Scala, but
we don't care.
Yeah, well, I care, to be honest, right? Because you don't care as a performance guy.
As a performance,
right? So from a usability and IDE experience,
of course,
different thing.
Yes.
So the problem with Java is, right, that the DSL is not optimized for Java. So you can do everything with Java, but it can be pretty cumbersome. Some of the things you have to do, working with extension objects and things like that.
It's a little more verbose,
yes,
for sure. So you get the best experience with, I would say, with the Kotlin DSL now, because even if you use Groovy, if you use dynamic Groovy, it's also convenient, but it's slow. Yep. Compile static Groovy is actually less convenient than the Kotlin DSL.
Yes, it's not our DS. We cannot optimize for everything, right? We decided that for the static use case, we optimized for the Kotlin DSL, the whole IDE usability experience. But it works. All the Gradle plugins are written in Java. The Android plugin is written in Java, right? Yep. Many plugins are written with compiled static Groovy. Yep. So performance-wise, whatever, right?
Whatever you're comfortable with.
But there is the IDE usability experience. I would say that you will get the best. Yeah.
If you want to get into Kotlin anyway, this is a good opportunity.
So where do I configure the Android Studio Gradle daemon's memory?
That has nothing to do with Android Studio. You go into your Gradle properties and do org Gradle JVM args, and then you specify how much memory there. It's all documented in the user guide, the daemon chapter.
So another container question. Currently, we have a Docker container running on AWS EC2. Every time we kick a Team City job, we get a new machine. Cache does not work in my cases. What cache?
Which cache, yes. Right?
So the dependency cache we talked about.
Okay,
right?
there's two things. So the remote build cache will definitely work, at least for tasks that are properly cacheable.
And I would say a remote build cache is essential in a disposable build environment, right? Otherwise, you will really suffer from performance.
And the dependencies. You should look into doing something like Travis CI does. They have this concept where you can tell it about directories that it should save and then get back next time that project is built. So like Travis CI and Circle CI, they all have this concept where you can say, hey, take the .gradle/caches directory, store it in some Amazon S3 bucket, and get it back next time I build, so that my local caches are there again. So maybe you can look into something like that for your setup as well.
But there is something, we are aware of this problem, we will provide some form of easier solution out of the box, regardless of CI tools. So that is something we will, hopefully this year.
It'll have to get easier than relying on what your CI provider provides. Yeah.
What exactly is Android Studio Gradle doing when I do a project sync? Right, we haven't talked about Android Studio sync time. The last sync I did took over 2 minutes. How can I profile what Android Studio is doing with Gradle during the sync? Configure build node in the Gradle sync tab in Android Studio alone took over 1 minute.
Okay, there's several things that are going on. So what Android Studio does is, of course, it needs to get the information about your Gradle project to configure the Android Studio projects. So what it needs is what projects are there, what are their dependencies mostly, what are the source folders. So it gets that information. It means it has to configure your project, it has to resolve quite a lot of dependencies, and then build a model which it ships back to Android Studio over serialization protocol. And then it has to take that information and do a bunch of API calls to the IntelliJ APIs to set up the project. And what the next thing it does is it will generate your resources because you'll need them to edit your code in the IDE. So it'll also call generate debug resources or whatever variant you're currently editing. So those are the things it does. There are a few inefficiencies currently, which are being fixed by the Android plugin, by the Android team as we speak. The first is right now it gets the dependencies for all variants, even though it only needs one, which is a big overhead. That's going to be fixed. And second of all, right now it does 2 build invocations, one to get the model and the other to generate the resources. That's also going to be fixed to do this in one step.
So at the moment you pay 2 times the configuration time price, and in the future will be only 1 time the configuration time.
That's exactly right. So if you want to measure what's going on there, you can approximate it by measuring on the command line how long it takes to call generate debug resources. At least that's what it's going to be like in the future with the single variant dependency sync. Yeah. On the Android Studio side, well, it's 2 processes. So if you want to measure both, the impact on both, you need to attach your profiler to both Android Studio and Gradle.
But first of all, we are aware, everyone is aware that sync taking too long. The only thing you can do at the moment is to improve the configuration time.
Improve configuration, right? Yes.
And potentially use the variant filter. Would that help possibly?
I mean, that's improving configuration time.
Yes. So, and then be a little bit more patient. And especially for sync time, I think you can expect a lot of improvements.
There will be big improvements this
year. And then lazy task, if lazy task is used and whatnot. Yes.
Yeah. So really, it's
unfortunate, right? We feel with you. But things will
also
improve.
Do generate debug resources. Use the Gradle profiler to profile an up-to-date generate debug resources, because it could be that you have some task that's out of date when it shouldn't be. So you might be suffering from that as well, right? That the resources shouldn't be regenerated if it's not necessary. So that might be part of those 2 minutes. So really look into that.
It's a very important point, yes. So it's not just improve the configuration time, potentially also improve some others.
Yeah.
So the generate resource processes step.
Yeah.
Is there a way to accept terms of services automatically when running --
You apply the scan plugin.
Yeah, so it should we should at one point provide just some simple properties where you can do that. But at the moment, just look at scans.gradle.com and then apply the build scan plugin to your project. You can also do that just in your user home in an inner.gradle file, right? This is all described at scans.gradle.com, how you can do that.
Yeah.
I would opt into anonymous customer projects with NDA reports if Gradle would measure stuff for you to see what happens in real-world scenarios. Write an email to performance@gradle.com, and we will work. And then we can get into private email communication mode, and we will work something out with you.
And we've actually talked about this this week. If we should have some kind of anonymous usage statistics, which is like less than a scan. A scan contains a lot of information about your project that you might not want to share, but like some statistics, project size, and stuff like that. We'd be really interested to get this on a wider scale as well.
But right now, just contact us, and you're not the first organization we're doing this with, and you will not be the last. So 3 more questions. So one is, do you think it's possible to introduce sort of strict mode to Gradle projects, where project opt-ins and say that Gradle can skip reconfiguration if it's build.gradle and dependency haven't changed?
Yeah, that's the configuration reuse that we've been discussing a lot. We may, if that turns out to be the biggest bang for a buck, basically. The thing is, all plugins kind of need to deal with that correctly. And the hard part about this is really ensuring correctness, because a plugin could just use java.io file and read something, and then not work correctly if we don't call it again. And we don't know that this file has changed. So we need some API for plugins to tell us, I'm going to read this file, please watch this file because I need it for configuration. So that's a bit of a problem. And nothing that can't be fixed, of course.
So the key thing is get configuration time down, right?
Yes,
so and there are incremental steps towards that. So one thing that is on our agenda to cache the whole dependency resolution tree. That is for me part of that idea to reuse state.
There are many things.
Yeah. But the key thing is make it fast, and we work on that from many angles.
And if your configuration time is slow, please get in touch with us. Send us a profiler, a snapshot, and we can look. Is it in your build? Is it us? Is it some third-party plugin? And really, I think the steps that I want to take are, first of all, make Gradle stricter about what you can do at configuration time, so that a lot of the bad practices are gone. and then maybe parallel configuration, maybe this kind of mode where we don't reconfigure if nothing changed, maybe other things. There's many potential enhancements. Yeah.
So my Android tests are slower to build than the app itself. Is this normal? I don't know. Depends, I guess.
Slower to run or slower to compile?
Slower to build.
Slower to build. Doesn't sound normal to me.
Yeah.
But yeah, we need to see the data.
Hard to say. Then I think the question is beyond the scope. Is there any recommendations on how to do caching if you're triggering Webpack builds? Right.
It's a bit out of scope, but I mean, what you could do is basically wrap your Webpack invocation in a Gradle task.
Yes.
And then declare all the inputs to your JavaScript build as inputs of that task, and declare all the outputs as outputs using the Gradle APIs.
That's the way to do it. Potentially break Webpack into multiple tasks, right?
Maybe,
and then to have more fine-grained.
Really, I'm not a front-end expert, so I don't know how hard it would be to figure out all the inputs and outputs.
But we have organizations doing that, right? With TypeScript and Gulp, I think. So yeah. So next, very important question. Our clean task takes way longer on Windows, 30 plus seconds than Linux. What might be going on there?
Windows is going on there.
Yes.
Windows is pretty slow on fine-grained file operations if you like delete lots of small files. So that's kind of expected. I'm sure there's things we could do to improve that. I don't know if there's some way to bulk delete or move and delete later.
So what we can say, right? Yeah, deleting is anyway. What we can say is it has come more and more to our attention. So what we will do over the next month is to get a better understanding of what exactly what exactly is the pattern on Windows, and then we will think about what we can do. But at the moment, in general, it is to be expected that Windows is slow. We don't know 30 plus seconds, right?
It depends on the size of the project again. I mean, 30 seconds could be outrageous, or it could be normal if you're a really big project.
So should we enable local build cache in CI environment? Yeah, answer is easy. It depends.
It depends, yeah.
If you have disposable builds, no, that the overhead you don't have, doesn't give you anything. If like us, right, you reuse agents, then absolutely, right.
It saves network.
Yep. Okay, should I change the Gradle version from 4.4 to 4.9? Absolutely, performance-wise. Right? So
always update.
We have a very big app with hundreds of dependencies and about 20 feature modules. We use Android Gradle plugin 2.3.3.
Yeah,
we
upgrade.
have all the build problems that you have mentioned. Is there any easy way to migrate to Android plugin 3.1.4, knowing that the main pain point is to tell when to use API and implementation and track dependencies between modules?
Yeah. So, I mean, the easiest is just start with API and cut it back later.
Yes.
Right. Just that's what you had before, basically. Like what compile really meant was API.
Yes.
So that's the easiest way, and then later start cutting back. And we need to provide better tools that tell you, like, hey, you've declared this as API, but it's not on your API.
Yes, absolutely.
Right? We will make this easier, but right now, just declare everything as API to get onto 3.x.
You will have good performance benefits if you have a good separation between API and implementation. The avoidance will be much better. But even if everything is API going to Android 3.x, oh my goodness, compared to 2.x, don't even try. I mean, seriously, don't even try to optimize the 2.x performance. The most important thing you have to do, move to 3.x. Things will dramatically change just by that. Right? Even if there's so much other optimizations you can do. I was using what Android Studio has configured automatically, I guess the Gradle version, but Scan points out that I'm not using the latest version. Here we go. That's the value of Scan. Now you have insights. Oh, why is it not using the latest version? So yeah, I mean, Android Studio, as you upgrade Android Studio, they will pick later a Gradle version as the default, but we release more often than Android Studio.
Change the Gradle property, the Gradle properties.
Change in the Gradle directory in your root project, right? There is a wrapper.properties file, and that's where you can change the version. The generate debug resources task, even preceded by clean, runs very quickly from my project, 1 to 2 seconds. Is there anything else I need to do to approximate Android Studio sync process?
Well, there's a lot of dependency resolution going on right now that is not necessary.
Yeah.
Right. So it's not a perfect approximation at the moment.
But I would say if your time is then otherwise 30 seconds, send an email to performance@gradle.com.
Sorry.
If that's the same person who had 30 seconds sync time, right? that looks weird.
Yeah.
But anyhow, ping us on performance at Gradle.com. We're very interested to look at this and can also forward it to the Android
It could be
people.
if you have like lots and lots of variants, then that would mean lots of dependency resolution. But yeah, it would be great if we could just look into that project together.
That looks a bit weird.
Yeah,
2 seconds, then 31. Yeah.
For sure.
Awesome. Those
all.
were the questions. Great.
Really good
Thanks for all the questions.
Thanks.
Excellent.
Yeah, that was great. All right, that's all we got.
Cool. Thanks, Stefan, for taking the time. I really enjoyed it. Let's
fun.
continue, everyone, to work on better build performance. And have a great day, have a great evening, wherever you are. Goodbye.
See you, everyone.